hit 70 kDp, it's actually 69.5, that's when we're going to start having characteristic radiation occurring. Characteristic radiation, again, we have electron in, remember SCADE, right? So we have an electron coming in, it's going to hit an inner shell electron and it's going to knock that inner shell electron out. In the process, that is ionizing, right? We're knocking the electron out. We're going to have something known as a characteristic cascade happen. A characteristic cascade means that the outer shells are going to be unstable with an inner shell missing a spot. So what it'll do is it'll actually drop an outer shell electron into that inner shell to fill that vacancy. That is known as a characteristic cascade. Each of these shells have energy levels, okay? So the closer you are to the nucleus, the more energy you have. 69.5 is the energy level for the K shell, which is that first level right outside the nucleus, of a tungsten atom. This is again happening in the X-ray tube. So all of this is happening on tungsten with an atomic number of 74. So you have to know that. The atomic number of 74 means that the K shell has an energy of 69.5, okay? So if I have an X-ray come in at stronger than 69.5, which we don't work with decimal point KVs, that means that if it comes in at 70 kVp, it has enough energy to knock that inner shell electron out. So the electron comes in, knocks this inner shell electron out, and then that outer shell is going to drop in to fill that vacancy. The next shell, the L shell, saying that's the shell that fills the gap, it can't actually skip and be one of these other shells, but we're not going to get into that. The next shell has an energy level of 12, which means 69.5 minus 12 leaves 57. So the X-ray that is being produced, notice that it's kind of short wavelength, high frequency, is going to be 57 keV, okay? So once I start shooting X-rays at 70 kVp, the highest energy that I could get from characteristic is 57. But I could still get, if I shoot 70 kVp, I could still get 70 kVp from Bremsstrahlung, right? Or 69 kVp. But the highest characteristic radiation that I'm going to get is 57. So the way I think about this with the binding energies versus the total energy, right? If you guys haven't been explained this, this is how I think of it. It's my ADHD way of thinking of it. A student actually explained this to me, so I love it. So the closer you are to the nucleus, the stronger the binding energy, right? Binding energy and total energy are going to be inverse of each other. So if you guys ever been to like the playground or something, or with your niece or nephew, and you grab your niece or nephew and you like give them a big hug and you like spin around in a circle, right? You're keeping them very close to you. You have a very strong binding energy. What you don't have is a lot of total energy. So if I'm spinning in a circle, right? If I were to accidentally let go of my niece or nephew, they're just plopping right down there, right? That's the total energy. So they had a lot of binding energy. I can't have somebody come running in and like stealing the kid because I've got them, right? But total energy, plop, they're done. They just have used all their energy on the binding part. Total energy can be more if I hold the kid out like this, right? And if I'm swinging them around by their arms, now I don't have as much binding energy, right? It's very easy for someone to come in and like knock my hand loose and I could accidentally lose them and kid goes flying, right? So in that case, I don't have as much binding energy, but I have more total energy as they go, okay? So when I have an inner shell electron, it has more binding energy, 69.5. The next shell has 12, it's kind of like a little bit further out. So when that binding energy is dropping into this one, I have total energy to lose. That's where the 57 comes from, okay? A lot of people don't understand that part, and that's okay. Anyways, the characteristic cascade means that it's going to keep doing that, and each of these energy levels lose more and more energy. The N shell has an electron energy, binding energy of 2. So the X-ray that it's producing is 10. 10 isn't in our energy spectrum. We don't care about 10 keV. So it's going to be produced, it's going to add to patient dose, but is it really going to matter? Not so much. Again, characteristic will be ionizing because we are going to be knocking an electron out. Bremsstrahlung is not ionizing because we are not knocking any electrons out of that tungsten atom. Electron in, right? Straight line in, straight line in, photon out, wavy lines out, okay? If you write all of this out, just like how I have it, promise you, you are going to have so much less test anxiety. I pinky swear promise it's going to make your life so much easier.